Oh, wow.
There you go.
It's huge.
Locked away in ancient rock, a prehistoric treasure trove awakens from its 65 million year slumber. Exquisitely preserved fossils unveil creatures beyond imagination, shattering long-held beliefs about dinosaur evolution. As layer after layer of sediment reveals its secrets, scientists stand in awe of nature's time capsule. What revolutionary insights will these newly unearthed remains provide?
Paleontologists working their entire lives searching for dinosaurs, and they will never even get close to a T-Rex.
Prepare for a journey into Earth's distant past that promises to revolutionize our understanding of life before humans. First ever Tyrannosaur meal. The first glimpse into a tyrannosaur's diet came not from massive bones or teeth, but from a surprisingly picky eater. A young Gorgosaurus, a cousin to the mighty T-Rex, became fossilized with its last meals preserved in its stomach cavity. This recent discovery, unearthed in Alberta, Canada, provided a fascinating window into the early life of a fearsome predator. The Gorgosaurus in question was estimated to be between 5 and 7 years old, a teenager in tyrannosaurid terms. While adults are known to have taken down large prey like duck-billed dinosaurs, this juvenile had a taste for something smaller. Its stomach contained the leg bones of two centipes, a turkey-sized plant-eating dinosaur. Interestingly, the Gorgosaurus wasn't interested in the whole carcass. It appears to have dismembered the centipes, devouring only the hind legs and leaving the rest behind. Paleontologists believe this selective feeding behavior highlights the difference in hunting strategies between young and adult tyrannosaurs. This Gorgosaurus's weak bite and teeth compared to their adult counterparts suggests they were better suited for swift attacks on smaller prey rather than grappling with massive dinosaurs. The discovery sheds light on the ecological niche these young predators occupied, filling in a gap in our understanding of tyrannosaur development. While the image of a T-Rex chowing down on a Stegosaurus is iconic, this fossil reminds us that even the most fearsome predators start small, with a penchant for dinosaur drumsticks. Never before seen Titan. A forgotten giant has lumbered out of the past. Paleontologists in Spain have unearthed a new species of titanosaur, a long-necked behemoth estimated to be as colossal as a basketball court. This discovery, named Garambatidan morelensis, hails from 122 million-year-old fossils and sheds light on the secretive origins of the sauropod family. Garambatidan morelensis, belonging to the same group as iconic dinosaurs like Diplodocus and Brachiosaurus, pushes the boundaries of size for early sauropods. However, unlike its well-known cousins with their highly specialized features, Garambatidan's bones reveal a simpler design. This lack of distinctive features hints at a more primitive role in the sauropod family tree. The discovery of Garambatidan is groundbreaking because it rewrites the story of sauropod evolution. Previously, the origin of these gentle giants remained a mystery. But the location of these fossils in Spain, on the ancient Iberian Peninsula, offers a tantalizing clue. Could this be the birthplace of the sauropod lineage? The possibility is electrifying. Garambatidan is more than just a colossal dinosaur. It's a missing piece of the prehistoric puzzle. This discovery opens a new chapter in our understanding of sauropods, suggesting a wider range of early forms and adaptations. The Spanish excavation site holds immense potential, and paleontologists are eager to unearth more. Every additional bone, every scrap of fossilized evidence brings us closer to a complete picture of this enigmatic giant and the sauropod family's fascinating evolutionary journey. Footprint-covered cliff. In Denali National Park, Alaska, researchers have made an astounding discovery: a 20-story cliff face covered in fossilized dinosaur footprints. The 218-foot, 66-meter rock face, nicknamed the Colosseum, preserves tracks from a diverse array of dinosaurs that lived around 70 million years ago during the late Cretaceous period. The site was originally a muddy area surrounding a watering hole on a large floodplain. Various dinosaurs, including duck-billed and horned plant-eaters, carnivores like raptors and tyrannosaurs, and even flying reptiles, left their footprints in the mud. Over time, tectonic activity lifted and tilted these tracks, creating the illusion of dinosaurs walking vertically up the cliff. Researchers were initially stunned by the discovery, as many tracks had been filled in by sediment and were only visible under specific lighting conditions. Upon closer inspection, they found incredibly detailed prints showing toe shapes and skin textures. The site also contains fossilized plants, pollen, shellfish, and bird tracks, offering a comprehensive view of the ancient ecosystem. This remarkable find provides an unprecedented opportunity to study dinosaur behavior and the environment of prehistoric Alaska. Mortal Kombat Battle. A stunning fossil unearthed from China's Liaoning province in 2012 captures a prehistoric mortal combat between two species from about 125 million years ago. The fossil, preserved by a sudden volcanic eruption, shows a badger-like mammal called Rhepenomammus robustus, locked in battle with a young Psittacosaurus, a plant-eating horned dinosaur. The mammal, measuring 18.5 inches long, appears to have overpowered the 47-inch dinosaur. Evidence suggests R. robustus was the victor, with its teeth embedded in the dinosaur's ribcage, likely delivering a fatal blow. The mammal's paws are also gripping the dinosaur's jaw and shin. This discovery challenges long-held assumptions about dinosaur-mammal interactions, providing some of the first concrete evidence of a mammal predating on a dinosaur. Previously, scientists believed dinosaurs were primarily the hunters of mammals, not the other way around. The fossil comes from an area nicknamed China's Dinosaur Pompeii due to the excellent preservation of creatures by volcanic mudflows during the mid-Mesozoic era. This remarkable find offers new insights into the complex predator-prey relationships of the prehistoric world. Fossilized voice box. The discovery of an 80-million-year-old fossilized voice box, larynx, belonging to Pinacosaurus grangeri, an armored ankylosaur dinosaur, has provided new insights into dinosaur vocalizations. This fossil, found in Mongolia in 2005, is the first larynx discovered in a non-avian dinosaur. Analysis suggests that Pinacosaurus grangeri's vocalizations may have been more diverse and melodious than previously thought. The larynx is described as kinetic and large, similar to birds capable of producing various sounds. This challenges the assumption that dinosaurs only made crocodilian-like noises. The fossil's larynx contains a large cricoid and two long bones for adjusting airway size, indicating the ability to produce a wide range of sounds, including rumbles, grunts, roars, and possibly chirp-like noises. However, due to their size and different vocal mechanisms, ankylosaurs likely didn't sound exactly like modern birds. This discovery contributes to understanding the evolution of vocalization in archosaurs, which split into bird-like and crocodile-like groups about 250 million years ago. The finding suggests that complex vocalizations may have been more common among dinosaurs than previously believed, potentially used for courtship, parental behavior, defense, and territorial calls. Animated missing link. Paleontologists have discovered a new species of primitive duck-billed dinosaur in Chilean Patagonia, named Gonkoken nanoi. This herbivorous hadrosaur, measuring 11.5 to 13 feet long and weighing 1,300 to 2,200 pounds, lived around 72 million years ago during the late Cretaceous period. The discovery is significant as it's the first primitive hadrosaur found in the southern hemisphere. Fossils of at least 3 individuals, both adults and juveniles, were unearthed in a bone bed, suggesting Gonkoken nanoi lived in social groups. Gonkoken nanoi represents an evolutionary link between older and younger hadrosaur species. Researchers believe it or its ancestors originated in the northern hemisphere and migrated south before more advanced hadrosaurs evolved. The species likely thrived in the warmer southern climate with diverse plant life. This finding challenges previous understandings of hadrosaur distribution and evolution. It suggests that primitive hadrosaurs coexisted with more advanced forms in the southern hemisphere. The discovery also raises the possibility that Gonkoken nanoi may have reached Antarctica and survived until the end Cretaceous extinction event. Blade-like armor. Paleontologists in the UK have uncovered a new species of armored dinosaur named Vectipelta barretti on the Isle of Wight. This ankylosaur, characterized by blade-like spikes protruding from its heavily armored body, represents a significant find in dinosaur paleontology. The partial skeleton of Vectipelta barretti, including distinctive scythe-like osteoderms, was discovered in 1993 at the Wessex Formation and fully excavated the following year. Additional bones were recovered in the late 1990s, with the Dinosaur Isle Museum acquiring the specimen in 2021. Initially thought to belong to the Polacanthus genus, closer examination revealed Vectipelta barretti as a distinct species. It features unique characteristics in its neck and back vertebrae, as well as more blade-like and recurved spikes compared to Polacanthus. Evolutionary comparisons suggest Vectipelta barretti is not closely related to other known ankylosaurs from the Isle of Wight, such as Polacanthus and Hylaeosaurus. The fossils date between 134 and 143 million years old, fitting between the known ages of these other species. A godly raptor. Researchers have uncovered a new species of dinosaur in Utah, named Yanni smithi. This plant-eating, raptor-like dinosaur lived approximately 99 million years ago during a period of significant climate change that led to the extinction of several dinosaur lineages. Yanni smithi is believed to be a crucial missing link in dinosaur evolution, bridging the gap between early bird-like dinosaurs and the later duck-billed dinosaur group. This discovery provides valuable insights into the transitional period of dinosaur evolution and adaptation. The species name, Yanni, is derived from Janus, the Roman god of change, who is typically depicted with 2 faces. This name was chosen to reflect the dinosaur's position at a pivotal point in evolutionary history, metaphorically looking both backward and forward in time. The researchers describe Yanni smithi as standing on the precipice, able to represent both the past ecosystems of North America and the rapidly approaching future changes. This discovery highlights the dynamic nature of evolution and the impact of environmental changes on species development. Feather X-rays. Recent research has revealed that dinosaur feathers were more similar to modern bird feathers than previously thought. Scientists reanalyzed fossilized feathers from non-avian dinosaurs using X-ray scans, leading to this surprising discovery. The study focused on fossils from dinosaurs such as Sinornithosaurus and Confuciusornis. These fossils contain traces of corneous beta proteins, formerly known as beta-carotins, which are crucial for strengthening feathers for flight. When compared to the same proteins in modern zebra finches, Taeniopygia, researchers found remarkable similarities. Initially, scientists expected to find a more primitive version of these proteins in dinosaur feathers. However, the results indicate that the same proteins have been present in feathers for millions of years, far longer than previously believed. This discovery suggests that the chemical composition of feathers has remained largely unchanged over an extensive period of evolutionary history. It provides new insights into the development of feathers and their role in the evolution of flight. The research highlights that the chemistry of modern bird feathers is much more ancient than previously understood, deepening our knowledge of the evolutionary links between dinosaurs and modern birds. Communal nests. New research suggests that bird-like dinosaurs, specifically Troodon formosus, exhibited communal nesting behaviors 74 to 66 million years ago. Unlike most dinosaurs that laid eggs en masse and buried them, Troodons shared nests where multiple females laid over 20 eggs together and brooded them to keep them warm. Analysis of fossilized eggshells revealed that Troodons were endotherms, warm-blooded, maintaining body temperatures around 42 degrees Celsius. They could also enter a state of torpor, lowering their temperature to 29 degrees Celsius, demonstrating heterothermy similar to that of modern birds. The study, published in the Proceedings of the National Academy of Sciences, examined eggshell mineralization patterns, comparing them to those of modern birds and reptiles. Troodons retained slow, reptile-like eggshell formation despite evolving bird-like traits. Researchers estimated that a female Troodon could lay 4 to 6 eggs per clutch. The presence of over 20 eggs in nests suggests multiple females contributed to a single nest. This discovery provides insights into the evolution of endothermy in dinosaurs and the transition from cold-bloodedness to warm-bloodedness. It also demonstrates complex social behaviors in these ancient creatures, similar to some modern birds. Patagodon majorum, a titanosaurian sauropod discovered in Patagonia, Argentina, has fascinated paleontologists since its announcement in 2014 and formal naming in 2017. This colossal dinosaur lived approximately 101.62 million years ago during the late Cretaceous period. Unearthed from the Cerro Barcino Formation in Chubut Province, Patagodon's remains were first found by a farm laborer in 2010. Extensive excavations between 2013 and 2015 yielded over 200 fossils, including 130 sauropod bones from at least 6 young adult individuals, making it one of the most completely known titanosaurs. The holotype specimen, MPEFPV 3400, includes vertebrae, ribs, limb bones, and shoulder and pelvic girdle. Elements, initially thought to be the largest known land animal, with estimates of 40 meters in length and 77 tons in weight, current research places Patagodon at around 31 meters long and 50 to 57 tons. While still immense, these dimensions suggest it may have been comparable to or slightly smaller than some other giant titanosaurs like Argentinosaurus and Portosaurus. Patagodon possesses unique anatomical features, including specific characteristics in its vertebrae, scapulae, humeri, ischia, and femora. A notable feature is the presence of hyposphene-hypantrum articulations between only one pair of vertebrae at the scapular blade level, likely a weight-bearing adaptation not seen in other sauropods. The dinosaur inhabited a forested floodplain dominated by coniferous trees. Its discovery has significantly contributed to our understanding of titanosaur diversity, anatomy, and evolution, providing valuable insights into the biology and ecology of these prehistoric giants. Despite ongoing size debates, Patagodon remains one of the largest known dinosaurs, exemplifying the extraordinary scale of Mesozoic life. Megalosaurus. Megalosaurus, meaning great lizard in Greek, was a large carnivorous theropod dinosaur that lived during the Middle Jurassic period, about 166 million years ago. It holds the distinction of being the first non-avian dinosaur genus to be validly named in 1824, with its type species, Megalosaurus bucklandii, named in 1827. The only certain remains of Megalosaurus come from Oxfordshire, England. Initially misidentified as a gigantic 20-meter lizard, later research revealed Megalosaurus to be a bipedal predator approximately 6 meters long and weighing around 700 kilograms. It had a robust build with strong hind limbs, short but powerful forelimbs, and a large head equipped with long, curved teeth. Megalosaurus played a significant role in early dinosaur research. It was one of 3 genera used by Richard Owen to define Dinosauria in 1842. A model of Megalosaurus at Crystal Palace increased public interest in prehistoric reptiles. Although many species were initially classified under Megalosaurus, modern understanding recognizes only Megalosaurus bucklandi as valid. The lack of a complete skeleton has made it challenging to determine its exact appearance and size, but comparisons with related Megalosauridae have helped scientists reconstruct its likely features. Tyrannosaurus. Tyrannosaurus rex, discovered in the early 1900s, has captivated the public imagination for over a century. Initially portrayed as an upright, tail-dragging creature, our understanding of Tyrannosaurus rex has evolved significantly. Modern research reveals Tyrannosaurus rex lived 68 to 65 million years ago during the late Cretaceous period. It was one of the largest land predators, with a horizontal spine and raised tail, unlike earlier depictions. Despite popular misconceptions, recent studies suggest its small arms may have been more useful than previously thought. Contrary to earlier beliefs of Tyrannosaurus rex as a fast runner, biomechanical simulations indicate it was limited to a fast walk or jog, with a top speed of about 30 kilometers per hour due to skeletal stress limitations. The question of feathers on Tyrannosaurus rex remains debated. While smaller relatives like Dilongparadoxus and the larger Yutyrannus were feathered, recent Tyrannosaurus rex skin fossil analysis shows scales. The possibility of feathered juveniles losing feathers in adulthood is considered. This ongoing research demonstrates that our understanding of even well-known dinosaurs like Tyrannosaurus rex continues to evolve, highlighting the dynamic nature of paleontological science. Giganotosaurus. Giganotosaurus was one of the largest carnivorous dinosaurs that roamed modern-day Argentina during the late Cretaceous period, approximately 99.6 to 97 million years ago. This formidable predator possessed 76 teeth, each about 8 inches long, which it used to hunt and consume large sauropods. Weighing around 10 tons, Giganotosaurus slightly outweighed Tyrannosaurus rex. Though it wasn't the largest theropod of all time, that title belongs to Spinosaurus. Evidence suggests Giganotosaurus may have preyed on Argentinosaurus, possibly hunting in small groups to take down such massive prey. While it was the largest carnivorous dinosaur in South America, Giganotosaurus lived about 30 million years before Tyrannosaurus rex appeared in North America. Skeletal analysis indicates it was likely faster than Tyrannosaurus rex, potentially reaching speeds of 20 miles per hour in short bursts. Interestingly, despite its impressive size and speed, Giganotosaurus had a relatively small brain for its body size. The species was discovered in 1993 by amateur fossil hunter Ruben Dario Carolini in Patagonia, Argentina. To date, only one species, Giganotosaurus carolini, has been identified. The most complete specimen found is about 75% intact. Giganotosaurus belongs to the Carcharodontosauridae family, closely related to Carcharodontosaurus and Maposaurus. Archaeopteryx. Archaeopteryx, which is a primitive bird discovered in Germany, had claws at the ends of its wings and could fly, albeit not as acrobatically as modern birds. Archaeopteryx had fused collarbones, a crucial development for efficient wing flapping and gaining altitude. This adaptation allowed it to hunt and nest in trees. Archaeopteryx fossils, found throughout the 20th and 21st centuries in Germany, revealed intriguing features like feathers on its feet, a characteristic no longer present in modern birds. While not an agile flyer, Archaeopteryx was an insect eater that could take advantage of opportunities like scavenging from carcasses. The discovery of Archaeopteryx fossils sparked debate about the relationship between birds and dinosaurs. However, due to insufficient evidence, this theory was shelved for over a century. Ultimately, while pterosaurs became extinct at the end of the Cretaceous period 65 million years ago, the descendants of Archaeopteryx flourished, leading to the diverse bird species we see today. Diplodocus. Diplodocus was one of the longest land animals that ever lived, inhabiting Earth during the Jurassic period, approximately 154 to 150 million years ago. The largest complete Diplodocus skeleton measures an impressive 88 feet in length. However, isolated bones suggest some individuals may have reached lengths of up to 108 feet, equivalent to 3 school buses. Despite its enormous size, Diplodocus had a relatively small head, measuring only 24 inches long, with a fist-sized brain cavity. Its long neck allowed it to reach high into trees to feed on tough, woody vegetation like pine needles. Weighing approximately 16 tons, Diplodocus had a massive body that housed an extensive digestive system. This allowed it to process tough plant material for extended periods, efficiently extracting nutrients. As a result, Diplodocus didn't need to chew its food. The dinosaur's teeth were limited to a single row of blunt, peg-like structures at the front of its jaws. These teeth functioned like a comb, enabling Diplodocus to rake leaves from twigs. This unique adaptation, combined with its long neck and efficient digestive system, made Diplodocus a successful herbivore in the Jurassic ecosystem. Mosasaurs. Mosasaurs were formidable marine reptiles that dominated the oceans during the Cretaceous period. Closely related to snakes and monitor lizards, these highly adaptable creatures evolved into numerous species, thriving in various aquatic habitats worldwide, including freshwater rivers. As apex predators, mosasaurs had a diverse diet that included fish, sharks, plesiosaurs, sea turtles, seabirds, and even smaller mosasaurs. Their size varied greatly, with the largest species like Mosasaurus and Tylosaurus reaching lengths of 30 to 50 feet, surpassing even Tyrannosaurus rex. However, many smaller species were comparable in size to modern dolphins. Most mosasaurs shared common characteristics: a long, serpentine body with a powerful tail for propulsion, paddle-like limbs for stability, and a large head with flexible jaws. Their distinct dental structure featured 2 rows of conical teeth, perfect for grasping and swallowing prey whole. Mosasaurs emerged during the Cretaceous period when ichthyosaurs and plesiosaurs, the previous dominant marine reptiles, were in decline. They are believed to have evolved from terrestrial lizards that adapted to aquatic life by the mid-Cretaceous. Fossil discoveries on all continents, including Antarctica, show that mosasaurs rapidly evolved and spread throughout the world over the following 20 to 30 million years. The reign of mosasaurs came to an end approximately 65.5 million years ago, coinciding with the extinction of non-avian dinosaurs. While the exact nature of their extinction, whether sudden or gradual, remains unclear, their disappearance marked the end of an era for large marine reptiles. The oceans have not since witnessed reptilian predators of comparable size and dominance to the mighty mosasaurs. Iguanodon. Iguanodon, meaning iguana tooth, was named for its teeth resembling those of modern iguanas, albeit much larger. This herbivorous dinosaur lived approximately 120 million years ago, during the early Cretaceous period. Fossils have been found primarily in Western Europe and North America, with some discoveries in Asia and Britain. Similar species existed in Africa and Australia. Iguanodon was one of the largest iguanodontid dinosaurs, reaching lengths of about 10 meters. Its posture and movement have been studied through fossilized footprints, suggesting it was primarily quadrupedal, but could rear up on its hind legs. potentially reaching heights over 5 meters. The dinosaur's hands were distinctive, with 3 middle fingers joined together and a freely moving little finger for grasping food. Its most notable feature was a sharp, bony thumb spike, which may have been used for defense or foraging. Iguanodon's dental structure was specialized for its herbivorous diet. It lacked front teeth, but had serrated edge teeth towards the back of its jaw. The jaw could move sideways, allowing for efficient grinding of plant material. This adaptation, along with the cheek muscles that could hold food, made digestion easier. The first iguanodon fossils were discovered in 1822 by Dr. Gideon Mantell in Sussex, England, making it one of the first dinosaurs to be scientifically described. A significant discovery occurred in 1878 in Bernissart, Belgium, where over 30 complete iguanodon skeletons were found in a coal mine, providing unprecedented insight into the species. The iguanodon was a substantial creature, weighing up to 5 tons and standing nearly 3 meters tall at the hips. Its size, coupled with its unique adaptations, made it a successful herbivore in the early Cretaceous ecosystem. Hadrosaurus. Hadrosaurs, or duck-billed dinosaurs, were among the most successful and populous dinosaurs of the late Cretaceous period, despite often being portrayed as easy prey. Recent research has revealed that these herbivores have several effective defense mechanisms. One primary strategy was herd behavior, with some groups numbering up to 10,000 individuals, as evidenced by a rare find in Montana. This provided safety in numbers and increased vigilance against predators. Hadrosaurs were also built for endurance running. Digital simulations of their muscle structure suggest they could outrun predators over long distances, though they may have been vulnerable to ambush attacks due to their lower top speeds. Their rapid growth was another advantage. Hadrosaurs reached full size in 10 to 12 years, compared to 20-plus years for predators like Tyrannosaurus rex. This faster maturation reduced their vulnerability period and increased reproduction rates. Many hadrosaur species grew to impressive sizes, sometimes matching or exceeding local predators. For instance, some Edmontosaurus specimens may have outsized adult Tyrannosaurus rex, while Shantungosaurus could reach lengths of 49 feet. While the ability to kick defensively is debated, their sheer size and weight could have made trampling a formidable defense. These combined adaptations, herd behavior, endurance, rapid growth, and large size allowed hadrosaurs to thrive alongside formidable predators and become one of the most successful dinosaur groups of their time. Yutyrannus. Discovered in China and described in 2012, was a significant find in paleontology due to its size and feathered body. Its name means beautiful feathered tyrant, reflecting its most notable feature. This tyrannosaur lived during the early Cretaceous period, approximately 126 to 124 million years ago. Fully grown, Yutyrannus measured about 29 to 30 feet long, stood 10 feet tall, and weighed 1 to 1.4 tons. Despite its size, it was covered almost entirely in filamentous feathers, making it the largest known feathered dinosaur. Yutyrannus belonged to the Proceratosauridae family and was closely related to Guanlong, Proceratosaurus, and Sinotyrannus. It inhabited a temperate rainforest ecosystem in what is now China, with a climate similar to modern British Columbia. The region experienced cold winters, with annual mean temperatures around 10 degrees Celsius, which likely explains the dinosaur's feathery coat for thermoregulation. The discovery of multiple specimens together has led to speculation about pack hunting behavior, possibly necessary for taking down large sauropod prey. Yutyrannus shared its environment with other dinosaurs like Sinosauropteryx, Bipiosaurus, and Psittacosaurus. We are coming to an end here today. Thanks for watching. And for such top listing videos, subscribe to our channel.